Hi guys, so I thought I would make this video on the exploring parent functions for you guys and developing the graphs so that you're not left to kind of do it on your own. Or if you did do it on your own, then you have a video to kind of back up your understanding so we can move along with domain and range after this, okay? So I know that functions at this point might seem frustrating to you, it might seem overwhelming, but please just stick with it. It's just, question by question, concept by concept, and try to stay focused as you're learning and just keep asking questions, okay? Please never feel bad for asking questions. We're all in this together, and right now this seems really difficult, but I promise if you stick with it, you'll look back and you'll see that you really do understand it. Okay, so we have 5 parent functions. So what I mean by a parent function is it's the simplest of a specific type of function. So for example, there are infinite different lines you can create. So when we're looking at linear relations, we can have positive slopes, negative slopes, steep lines, shallow lines, horizontal lines, lots and lots of different lines. But the parent of all of those is f at x equals x. So it's just the simplest line that there is, and kind of every other linear function can be created from transforming that function. So for each type of function as we go through, right now we're just looking at the parent. So it's also important to understand that when I'm talking about domain and range in these cases, I'm just looking at the specific parent function and not at all linear functions, for example, or all quadratic. So we're going to create a smart table of values to understand why each function looks the way it does. So I'm going to talk about that as we go, what that means to be a smart table of values. So a linear function f at x equals x, you just sub in the value of x, and f at x is just the same value as that x. So we can just put in negative numbers to positive numbers so that we're not just showing the positive quadrant. So I just put in -1, -2, 0, 1, 2, 3, and the corresponding f at x is the same because f at -2 is just -2, f at -1 is just -1, etc. So that just creates our nice straight line with a slope of 1 going through the origin, with a domain of any real number and a range of any real number. Okay, so hopefully that is super review for you guys. Okay, then with a quadratic, same thing. Okay, when you're going to square a quadratic, we can square negative and positive numbers. So I just start at -2, go up by 1s till I get to 3, and then I'm squaring that x value each time. So f at -2 is -2 all squared, which gives me 4, etc. So I go through and make the table of values, and it creates this parabola. Notice that it's a nice, well, kind of nice, smooth curve. Okay, you're not just connecting the dots and making it look linear. It's a curve. We have arrows on the end. The arrows on the end are important because they show the domain and the range. Okay, so the domain is any real number. You can put anything into x squared and it will work. Also, if you look left to right, any x value would have a corresponding y value. That works. And the range is any y value greater than or equal to 0. That's because when you square a number, no matter what it is, it becomes positive. And the lowest of those is 0, so which is non-negative. So 0 squared is 0. Also, if you look up and down vertically, you'll see that all of the y values exist above or equal to 0, and the graph does not exist when you go into negative y values. Okay, so hopefully those two were review. Now we'll get into the new parent functions. Okay, so this is the square root function. We've been looking at it a bit, but what does it look like? Well, here's where you really want to get into your smart table of values, because it doesn't make sense to go up from 0. Well, first of all, you can't put negative numbers in because you can't take the square root of a negative. So notice I did not start at -2 like the other functions. Also notice that I did not increase by 1 every time. Why do you think that is? Think about it. Look at the numbers I chose. Why did I choose those x values? Are you thinking? Okay, the reason is because if I was to put in 2, then my f at x value would be root 2, square root 2. That's not a point that I can graph very easily. And square root 2, really, like, what is that, 1 point something? I don't really know what that is. So I picked a smart table of values. I picked the x values that I know would give me integer outputs, okay, integer y values. So I know that 4, the square root of 4 is 2, that's an integer. The next perfect square is 9, etc., etc. So that's what I mean about a smart table of values. You're picking x values that when you put in, know will get you a pretty number out. And by pretty, I mean integer. So when you plot these points, you get this curve, which will continue forever. So notice I didn't have room for 25, 5. That's fine. This still gives us a nice, good shape. So the domain is anything greater than or equal to 0. The range is anything greater than or equal to 0. Again, you can think about that by thinking about what you're allowed to square root, or you can look left to right for the domain and up and down for the range. Okay, for the reciprocal function, I actually added 1 row here. So again, here I put in very different numbers. I did start with negatives because you can put negatives into 1 over x. You can have negative fractions, that's fine. But notice I chose -2, -1, and -1/2, 0, and then 1/2, 1, 2. So why did I do that? Well, if I had only chosen -2 and -1, that doesn't really give me a good idea of what's happening after that, because it's actually only when you put fractions into this equation that the output is an integer, because 1 divided by -1/2 is actually -2. Okay, so if I had put in -1/3, I would have had -3, etc., etc. But putting these 3 points in on the left side and these 3 points in on the right side of the y-axis gives me a good enough idea of the shape to be able to draw the curve. So if you don't understand why it's going up to infinity like this, or why it's getting close to 0 like this, put in more numbers into your table of values and see that makes sense for you. Like put in -3, -4, -5. Put in -1/3, -1/4, -1/10. See what happens, and that should help you understand the shape of this curve. Notice too that at 0 it's undefined because 1 divided by 0 doesn't work. Okay, so this domain is any real number other than 0, and same thing with the range. Okay, finally, the absolute value function. So what those 2 lines do is it makes anything within those 2 vertical lines positive. So if you have a positive number already, it just stays positive. But if you have a negative number, then it turns it positive. So whenever you're having a bad day, just put those 2 lines in front of your face and you'll get positive. Okay, but for real though, so I can put in the same numbers as my linear function. It's just now that a -2 will become +2, etc. So it actually looks like, you know, a positive sloping line this way and then a negative sloping line this way. So its domain is any real number, but its range is greater than or equal to 0, because no matter what you put into that function, your output will be positive, or should I say non-negative. Okay, so that is the smart table of values to getting those graphs. So these are the 4 things I'm expecting you to be able to do as a result of this note. So please read those and treat them like a checklist and say, can I do those things? Okay, so now I'm going to move on to this graph. Oh boy, let me see if I can flip it around here. Rotate view clockwise. There we go. Okay, so in math, every function can be, so this is basically just summarizing what we just did. It's just in more of a chart form. Okay, so maybe you use a graphing calculator, GeoGebra, to already graph them, or you can just use what we just did with the by using the graphs above. But you can go through and take a look at what I put here. Okay, domain and range, you should be able to fill in from above and the graph, but you can check out the different features I put here. Okay, so go ahead and pause the video. You can copy them down. And what I talk about over here, these are just family members. So this is the most basic of the functions, and then this is what happens when you start moving them around or playing with them. So I think the linear and the quadratic you should be familiar. You know, one of them's in standard form, one's in vertex form. We'll be playing around a lot with these square root functions soon. So this just shows, you know, square root x is the parent, but this square root function has been moved around. This one has been stretched. Okay, so anything, you can add anything to square root x, and that would be in the family. Okay, and then here's reciprocal. So again, you can pause if need be. And you can see the different family members here. Okay, here I just explained what an absolute value is and what an asymptote is. Okay. Then these questions that we get to, which graphs lie. So before you look at this, you should try this on your own though. Okay, try to do this on your own. But which graphs lie in the first and second quadrants? Both. It's x squared and absolute value of x. I had put 1 over x, but that's not right because it's in the first and third quadrant. So first and third is x and 1 over x. Which graphs has asymptotes? 1 over x because you can't divide by 0. Okay. Graph these two on the same set of axes. What do they have in common? What's different? So they're both in the same quadrants. They're both symmetric about the origin. So they're symmetric if you were to flip them across the origin. But they have a different domain and range. And here's the asymptotes. Okay. Then x squared and absolute value of x. Okay. So they're both in the same quadrants. They both extend to infinity. And they're both symmetrical on the y-axis. So it's symmetrical this way. But x squared increases much more quickly. Okay, what's unique about root x? It's the only one that actually is only in one quadrant. Okay, so hopefully that helped you guys with your understanding of parent functions. That's a very crucial concept to understand as we move into domain and range. I really, really encourage you to spend time with those tables of values and understand why each parent is graphed the way it is. Okay, thanks for watching, guys. Hope you learned lots.